Hello everyone, welcome to this video. In this video we are going to answer this question that why do we require to study group theory at all. So the question here is, why were we studying about dihedral groups that we were doing in most of the previous videos, and why we have chosen that particular group or the symmetry group, and by studying that, and what consequences can we make out from it, so that we may understand that studying group theory is important in what sense, or how do we require why do we require to study group theory at all, right? Many students ask me that this is such an abstract subject, this is not used in real world situations. So here in this video I am going to answer all these questions. So we have been studying about dihedral group so far. So I have chosen that group because these kind of groups, they occur frequently in art and nature, right? Many artists and designers, they choose such designs which are symmetrical in nature, and moreover many of the decorative designs have one of the dihedral groups as a group of symmetry, right? So that is another thing. Moreover, many corporate logos, they are rich sources of dihedral symmetry. For example, you can see this logo here. This is a cyclic rotation group, so that means you can rotate it and it will give you the same structure by repeated rotation, right? So here this has 6 kind of symmetry. Why? Because you see, if you rotate it by an angle of 360 divided by 6, so that means 60 degree, so it will give you these same positions, right? So that is why. In the next figure you can see here that it has here in this figure it has 8 symmetries. So that means in total you have a 360 degree angle. So if you divide this 360 degree angle by 8, you will get how much? A 45 degree of angle. So that means in this case, if you rotate this figure by 45 degree, you will have different rotations, and by that you form a cyclic rotation group having symmetry 8, right? Similarly, the next figure corresponds to symmetry cyclic rotation group having symmetry 16. This is in accordance to this logo here, that in this logo you see these portions, they are total 16. So therefore when you rotate it 16 times, in that case it forms a cyclic rotation group having symmetry 16, right? Next is the Mercedes-Benz logo. So here this is a very famous one, all of you might know it, right? This has D3 symmetry, so that means it would be a dihedral group having order 6, right? Okay, so let's move further. The stars, they have D5 symmetry. How this is so? Because you see it has 5 such portions, so it forms D5 symmetry. So we have various symmetries over here of different kind of things which occur in nature and art and in corporate logos as well, right? Moreover, you can see that chemists, they classify molecules according to their symmetry. How is that so? For an example, we can look at this ammonia molecule NH3. Now according to our study in the subject of chemistry, we know this ammonia molecule is pyramidal in nature. So that means it has a pair of lone pair here, and moreover 3 hydrogens are attached to it in a pyramidal fashion. So in this case, this is also a symmetry group. It forms a symmetry group having symmetry D3 because all the hydrogens, they are equally oriented to this nitrogen from different sides, right? The next is mineralogist. They determine the internal structure of crystal. So mineralogist, how do they classify the different structures? They determine it using the X-ray projections. So once they do the X-ray projection of the given crystal, so once they collect the crystal, they do not know what is the structure of that crystal, they put it in X-rays, have the projections, and from that projection 2D projection that they obtain on 2D plane, right, they see what kind of symmetries do they obtain, and according to those symmetry, for example, you have this kind of structure here. This is some crystal and this is the 2D X-ray projection of that particular crystal. So from these dots you can see that it forms a kind of square, right? So therefore it has a symmetry of D4 because it resembles that of a square, right? So therefore the symmetry present in this case reveals the internal symmetry of the crystals, and accordingly the mineralogists, they can make conclusions based on this observation. The next is and in this crystal mineral in finding the symmetry of these crystals, the symmetry patterns are mainly D4 or D6 that occur commonly, and moreover mathematically we cannot construct crystals where Dn is the symmetry, where what is n is 5, so that means you cannot construct crystal having symmetry D5, or you cannot construct D7, D8 and so on, right, having where n is greater than 6, right. Next is the conclusion. That means from here what do we receive? So I have listed down my observations. So here it is listed that studying symmetry groups, that is essential to understand and explore various physical phenomena which occur around us, right. That I have shown you by the way of various examples, that how studying the group theory is essential to study other branches, right. Without it you cannot go through. So what you need to do is you firstly have to identify what kind of group structure that given phenomena or object possess. That is your task. Once you identify what is the group structure, then according to that what we do, we apply the operations of group, and thereafter we make conclusions out of that. So here for example in this case we consider the HIV virus, the cross section area of HIV virus. So here you see the outer shell here represents symmetry group, right, and it is of order 28, so you can write it as D28. Why this is so? Because you see the strands here of the outer shell, they are 28 in number, they all are 28 in number, so therefore this is a symmetry group having order 28, right. So once you know what is the group that is lying behind the physical phenomena or the object that we are studying, so here mathematics and in fact group theory that provides us with the methodology to deal with groups and to extract meaningful information from them. Whatever the extracted information that we receive, that is applied, and we use that particular knowledge and information to reach at conclusions about certain phenomena, right. So group theory, it provides us an important tool which enable us to make conclusion about various physical phenomena by the way of algebra studied in abstract sense. So this is the crux, and this is the answer to the question that why do we in first place study this group theory in such an abstract manner. So I hope you understood this one. Well, that is it for this video. Thank you for watching.